All right, let's get started. Welcome to my talk. It's a new talk called Software Engineering Completeness, knowing when you're done and why it matters. This comes from a lot of experience where I've asked people, well, I guess earlier in my career, people were asking me, am I done? And I would say yes. And we had different versions of what done meant. And later on, what's happened is where I've been running large projects, I'm asking a lot of people, are they done? And I get answers of yes, and it's completely different to what I expected to actually get done. So before we start, who am I? I am someone who's been using professionally C++ since 1991, so way back in the day, 30 plus years ago. All right, my professional career has mostly been system analysis and architect. I spent 21 years as a consultant, which just meant I've seen a lot of different places, a lot of different teams and projects. And these days I work in the Bloomberg ticker plant, which is where we take all the volumes of data around the world from various exchanges, process it and send it as the ticks you see on screens and what traders use to do their thing. So when I come to conferences, what do I like to focus on? I like to focus on practical software engineering based in the real world and something you could take away from it. This is, by the way, an engineering talk, not a code talk, right? I do lament to some degree in conferences. We have a lot of, here's a new spanner, here's some extra bolts we can do, all various tricky things that are very nice to use, and then we drop all that on the floor and we say, go build me an engine. I would like if I just showed a mechanic the various bits and pieces, but didn't talk about how to actually put the engine together. So this is more about the software engineering engine as opposed to the code itself. So let's begin. All right. I've asked the question of people a lot of time, are we done yet about something that needs to happen, some change? What I'm really asking is, are you done yet? All right. The we is kind of not really including me very much. And the answer usually is probably not, but you'll probably be told, yes, we are. All right. But the answer should probably, no, we're not done. And why is that the case? Why is we have such a bad delivery record in software engineering? Well, let's go, I guess, basics. What does done mean? All right, what is the dictionary definition of it? It's to work on something or bring it to completion or to a required state. To me, it means you are doing something and you've stopped doing it, so you believe you are done. Right? But what does done mean in engineering when we're talking about software products and stuff like that? Well, the Scrum Guide says its formal definition of the state of the increments when you meet quality standards. It's all kind of dry. But why do we even bother? I mean, surely we know when I say, are we done with some change? And you say, yes, we have a good comprehension. I'm ready to light on to the next piece, go on to the next piece of the story. So why bother? Well, the reason is that establishing a proper definition of done will create a shared understanding and a language for what we mean in our software delivery. All right? And a lot of times stuff is buried in this tribal knowledge and process expectations. It's like, oh, you got to be here a year, 6 months to figure out what we actually mean by done or what work we're actually doing. All right? We need to sort of, I think, get better at that. All right? As an example, all right, the goal of your project is to develop 10 new product features. That's your goal. And deploy them to the users. But you haven't deployed any of them to the users yet. So how done are you? What's your percentage done? We're pretty good with math in the engineering world, right? We're 0% done. I would say most people would not say that. They would say, hey, we've tested 5 of these and coded them up, so we're kind of half done. It's like, well, who sees this? The developer on his desk is seeing like half of these things working. That's not done. It's not done in any language that gets you money from the customer. All right? So this is not the way we want to do it. All right? The real question should be, what do we expect? Something pretty specific, and I'll talk about being specific later. Deployed and active everywhere in production. Accessible. That's, to me, a minimum definition of done. All right? Your users are actually able to use the thing or get the benefit from it. All right, I need some basic terminology before we get going, so we do have that shared understanding. What is the business value of software engineering? Okay, what are we doing? Because we're in it usually to make money. I guess open source doesn't do that. But in the main, where I am, we're trying to make money. It's called delivering desired product outcomes in incremental steps. That's what we are doing for our money, to get clients, happy clients, all right? Why are we doing it in incremental steps? Why not just a series of big bangs? Boom, huge amount of functionality just lands on the desk. Sometime later, another big bang, right? It's because we want shorter time horizons. We want to see value show up sooner rather than later. All right, there's lower risk involved when we drop incremental steps and as opposed to something big and huge. Right? Normally, the bigger the change, the more risk it's going to carry. All right, I don't know how big the CrowdStrike thing was, but right, you get a lot of disruption, anti-value, we'll call it, and you get better feedback from customers. I deliver something 2 years from now, and the customer sees it and goes, "That's not really what I wanted. You guys took a left turn in Albuquerque," as Bugs Bunny used to say. All right, so. Let's go on a bit more about the business value. So software value is only realized, you only actualize that value when it's available, all right? When your customer can use it. It has to be there, all right? And it has to be usable, meaning it works correctly, all right? Here's something that does X and it doesn't do it. And it must be reliable. It must do the same thing over and over reliable, or if you're a service or something that services requests, you must be up and running to service those requests. And these are the things that I'm going to call immediate value, what your customers are going to be into, all right? But there is other value in software that we must inject into the software, all right? And that is things like it has to be configurable, have to be flexible. When we want to do various things with it, we can make the software do it. Able to track down and fix issues quickly. The code base isn't so serpentine, it takes us like 2 weeks to figure out a production problem, right? And that it can evolve quickly. All right, so the first set is really observable by the customers. The second set is observable by the people who have to do the stuff, your developers, your engineers, I guess to some degree the managers who manage those. All right. So what types of changes, by the way, I'm always very interactive, what types of changes do we deliver to production as engineers?
Bug fix, new features.
New features, good one. Someone said bug fix. Anything else we deliver? We deliver this as well, turning on and off functionality.
Refactoring.
Yeah, well, you're getting a little far ahead of me. That is down the list. I'm going to have to whip down it. So configuration, right? We've brought some new thing online with new configuration. Yes, refactoring, deprecation, technical debt reduction. These are other things we bring. Anything else we bring to the party here? All right. We have things like the environment or infrastructure we live in. For me, I did a 2-year project moving us over to Linux from we call Big Endy and Big Iron, right? New compilers, new machine architectures. These are all things that we deliver. But what other types of change are we delivering to production? We're delivering broken functionality to production, all right? Or missing functionality. Hey, I thought it was there, it's not there. Or I didn't understand that's what you were asking me for, right? We deliver performance issues to production. I was actually looking at a piece of code that had already gone into production, and someone had left a print statement in the hot loop. And then when I told him about it, he went and looked at our metrics and seen that we had a huge spike in latency. But no one had noticed it, right? So we deliver this, right? Security issues, all right, that get delivered. We deliver something we can hack, all right? And we deliver system unreliability. So look, I've delivered this really good new change, but it takes my system down every 2 days or so because, it can't take the load, or I put something in that blows the queues or memory out. So these are things we deliver to production that we probably wish we didn't, all right? So what is in a commitment to deliver change? I need X done, I will deliver that to you, right? Commitment, right? And in software engineering, I've noticed a certain fear of commitment, all right? It kind of puts you on the hook, all right? But the first thing, you have to know what you're promising to deliver. Yeah, whatever it is you're talking about, I'll give it to you in 2 weeks, all right? That's not really going to give you a good outcome. So know what you're delivering. So what we use is acceptance criteria, all right? So we say, what are acceptance criteria? They're conditions that have to be satisfied so that this change is accepted by the user. And good acceptance criteria should have a few things. I'm not going to go into them, but clarity. In other words, I should be able to read this and understand. And the customer. You see there's and the customer at the end? All right, whoever you're delivering this to should be able to read it as well, not just like some very turgid engineering stuff. Concise, not a lot of fluff around it. Testability, in other words, I can say this is how you test for this thing, right? And hopefully it's observable by the customer, so he can see what's going on. It's not something really metaphysical, like trust me, great stuff is going on, and I'll deliver it in 6 months. All right, that's not really good for anyone, right? So good acceptance criteria should have these things about it. But the thing about acceptance criteria is they should describe what the change will do, not how it will be done. And the closer you get to a change that's to do with something in the code, the smaller and smaller that changes, these things converge and you start getting things like divide x by 2 and multiply by 100. That's like your acceptance criteria. No, that should be the result when I put this in. This is what I should be getting at. So it's something you can observe or test for. All right, so when you write acceptance criteria, right, who writes it? It's usually written by you or the product owner. And once you write some acceptance criteria, usually based on some requirements you've been given, you usually share it with your team. And I think this we're pretty good at. This is the piece we're not so good at. All right, sharing it with the guy you've promised it to. It's like, yeah, we're going to go in here, go into our, go up the mountain or go down the hole. We're going to figure it out. And we're going to give you something in X amount of time, right? So you validate that this is if it does this, is this what you're looking for? Yes. All right. And you can use, I don't use this too much, but it seems somewhat useful. By using given, when, then. It's called gherkin or cucumber or I don't know, there's probably other vegetables named for it. All right. But it means you use given, when, then. Given preconditions, when something happens, then these post conditions can be observed. All right, so I had one where, as part of what I was doing in Linux migration, where I was checking fleets of machines all through production as we were just changing over from Linux to over to Linux. And we had this thing where I had bunches of QA results coming in bad, and for anyone who did not have the tribal knowledge, it looked like we had broken a lot of production. But what happened was the reference machine was in just bad health, because something else had happened. It blew a disk out, or someone put a bad software load on it, right? So given I'm going to be scheduling daily tests on these two machines, when a reference machine has either building, meaning I'm rebuilding this machine, don't use it, non-standard software, some developer put his software on it, or a bad environment, we wait for checking a bad environment, then replace the reference machine with a machine from the backup list and repeat this check. All right, so this was my acceptance criteria for making sure I did not have machines giving me bad data in my QA of what I'm going to call the early stage production machines. Any questions so far? All right. So the other thing, you know what you're trying to deliver. What problem space are you working in? All right, so what is the domain of the problem you're trying to kill here? One is I have no idea, all right, and we're going to look into it, unknown, but I expected something small. This usually isn't a problem with the domain you're in, it's a problem with the priority, right? Someone just hasn't bothered to do something, so it's not really on their radar. But then you have simple changes, all right, and these are characterized by their known straightforward changes. In other words, we all agree there's probably a single solution, no real external dependencies, and it's low risk. We pass testing. We're pretty good. We have complicated problems, and complicated problems are more complicated than the simple problems, right? Because they have much more moving parts, right? And there's probably multiple correct solutions. We just have to figure what it is. But we do that through analysis. And then we have complex problems. And complex problems means you get a lot of unknowns, usually a bunch of external dependencies. And we know there's likely a solution, we just haven't quite nailed it down yet. So we're feeling around for it, right? And that usually has moderate to high risk, and you have to start managing that risk. Okay. And this, I don't know, has everyone ever seen, I think it's the SINFIN framework, right, which talks about problem domains. Here they are. You also have the chaotic, which just means all hell is breaking loose and you just have to staunch the bleeding. I'm not going to deal with that today. And disorder, meaning you don't know where you are. You're not even sure what the problem is you're trying to solve. Any questions? All right, requirements and scope. What is project scope? Anyone? We're all friends here. Later, yes. So project scope refers to the complete list of features or deliverables for a project. Right? Some people, quite a few people have kind of ambushed them, tell me what it is, and just kind of wander around, but this is really what it should be. All right? And these deliverables are usually created with requirements, which say, here's what we're doing, and can sometimes say, here's what we're not doing. Now, this is pretty good. What is the biggest killer, I think, of projects? Unsuccessful projects. What happens to the project? All right, you have this thing happen. Scope creep. Right, the other thing is you didn't understand the problem. All right, you thought it was a simple problem, it was much more involved. But scope creep. All right, expanding the list of features than what we originally agreed without doing anything to the timing or the other features you had promised. There has to be a give and take. All right, but sometimes you feel pressured. Listen, I just want to deliver it. As manager saying to me, can you deliver this in the same time? And it's like, yes, I can. But internally, you're like, I probably can't. All right, so that's scope creep. And the requirements you're going to have are going to tell you what the change should do. And it should be in bounded terms. It shouldn't be open-ended. So people can tack new stuff on as you're getting through it. And I gave a talk before called Redesigning Legacy Systems, which talked about scope creep as the killer of projects. All right, it really does kill projects. Right, the other thing, we're not even into the talk yet, but I gotta, like I say, nail down some things. What is timescale specificity? All right. Well, when will the change be done? All right, what is the timing? And I've had this in a large project say to people, when will this be done? Right? And I get these kind of answers, like whenever, I'll get to it. It's kind of out there somewhere. It'll be done soon. When is soon? Not quite sure. Yeah, soon. A couple of weeks. At least we're getting into a time frame I can work with now. A couple of weeks or a month. Well, what you should be asking for is a date. Right? What is the date? If you're doing the asking, and if you're doing the telling, here's the date I believe we are going to come in with what you're asking for. Now that I know the scope of the project. All right. I have a quick story where I had a tooling issue, and I needed the tooling fix to be done. And I went to the TL, and we had one of these checkpoint meetings. And he said, I think it was a Tuesday. Yeah, we'll be done by Friday. I think it was about the 8th of the month. And I said, a Friday? So that means, what is that, like the 11th of this month? He goes, oh, hold on. It's a date? It's the 30th of the month. All right, so the minute I tried to narrow that uncertainty down, he wanted to jump really long. And I'm like, okay, the end of the month, but you better have it done. You've committed to a date. But this is the kind of dates you need. All right. Now, most engineers, I include myself in that, have a misplaced optimism on timeline. You're a very happy-go-lucky engineer. You love what you do. Yes, Ben?
Do you think it's better to give one specific date commitment or dates and confidence intervals?
I'm just about to talk about that. You're ahead of me as usual, Ben. But yes, with confidence intervals. But who doesn't like having happy developers popping around, all joy? However, they usually assume a best case scenario and using a really poor definition of done. All right, done means I just coded up the solution on my laptop now. I'm done. It's like, oh no, you ain't. There is a whole bunch of red tape, if you want to look at it that way, until we see it in a customer's hands. Okay? And the other question that's forgetting is, yeah, this will take 3 days. You come back at the end of the week. Where is it? Oh, I'm not starting it for 3 weeks. All right, and you go, it's kind of a gotcha. All right, so when will it start? And the time scale estimation, the certainty you're going to have is going to be based on a domain type. If it's a relatively small, simple problem, time scales can usually be pretty confident. All right. Well, I'm delivering something over 6 months or a year or 2 years, it gets a lot more uncertain. All right, let's talk about good estimates. All right, why bother with good estimates? Can't I just say it'll be ready when it's ready? Usually, unless you're a really small business, that doesn't work, right? It creates trust, right? People who are relying on you or relying to get stuff out can say, this piece will be done on time, I'm pretty sure. He has a track record, because I get good estimates. How do you give better estimates? PAD? Yes, John, PAD. That's going to put that further down the list. It's not your first go-to move. You break changes into small pieces, right? The smaller the piece, usually the more definition you have, the more precise you can have your acceptance criteria. So break it into small pieces, right? That means you have specific scope and requirements, all right? And the one thing is to embrace empirical reality. I worked in a team one time, we did Scrum. I don't know if anyone's familiar with Scrum, but it's like a 2-week block of time. I have certain points of work. And I'm there, and we push up 28 points of work for the next Scrum. And I said, for the last 6 Scrums, which is 3 months, we've only ever done 18 points of work. Why are we putting 28 points of work on here? And it's like, well, that's what we were aspiring to. All right? That's what we want the people to feel like we should be looking for. It's like, yeah, but everybody who's dealing with your group thinks you're an unreliable group, right? So embrace empirical reality. And John, yes, lean towards a contingency fund for delays. If you're building a house or you're doing renovations, there's always a contingency fund. This is going to take 80 Gs, and 10 Gs of that is contingency, because we know we're going to find problems in your wiring, your fuse box, your dry rot, something wrong, we need a contingency fund. So you should build some of that in, not unbelievable amounts of it, but you should build a contingency fund for, will be done here best case scenario, but I'm only 50% confident, but in this time scale, I'm 95% confident, right, of what I'm going to get done. Right, and here's a key thing, is that as time progresses on projects, the uncertainty closes down. Right? Now, lots of times it closes down in a bad way. In other words, you say, as I'm halfway through the project, I'm now almost sure I'm not going to hit the deadline. Right? You need to communicate that back as soon as you can to your stakeholders. And I use stakeholders, customers, clients, the people who are waiting on this change. Right? There's nothing worse than a surprise that comes just out of like, surprise, we're not rolling out tomorrow. Right? As opposed to a month earlier, we're not going to make this, and we need to start planning for when we're going to actually get this thing out. All right, so that's something we need to communicate the information better. Now, are we done? I got a little disclaimer. I think it's a bit like Kate's this morning. All right, there is a school of thought, never commit to anything concrete. Right? Be slippery, be evasive. All right, because when you're evasive and vague, you can't really be called on that you failed something you didn't deliver, right? And that's more about, I think, giving people political cover. In other words, yeah, well, we never really said that. I mean, I was very slippery. I crafted my ACs in a way I could always make it, but not have the stuff you want done, right? It's like, it's almost legally. So this is about achieving positive outcomes, not being slippery, all right? So that stuff is out in my book. I'm out about the product, not about my own, I don't want to say ass, but okay. So let's begin. All right. I am going to attempt to build a software engineering completeness pyramid. All right, similar to, I forget the guy's name, Masvidal's pyramid of needs. Huh? Magwell, whatever his name is. All right. All right, him. I got inspiration for him. So we have this completeness pyramid of levels of done, levels of accomplishment of what we're doing. So I'm going to try and fill this in. So first thing, is development done? Okay, so have the changes been verified and applied as understood by the person who asked me for this? So if we met the change acceptance criteria, right? And sometimes we'll say, listen, we can't do them fully this time around, we're going to do partially, but we make that clear. And have we passed all tests driven by the validation system? Are we done with the change? Anyone want to put a hand up that we're done? There is room. Yeah, but I don't use all the room all the time. All right? I don't think we're done, right? Because it has to pass code review, right? To see if you've done this some sane manner. You often left print statements in it and stuff, all right? And it's been merged into a package for production release, all right? So it's ready for deployment. And I think now my group will go, we're done. Who's good with this definition of done? I used up all the slide, all right? Who's good with this definition? Who think it's an incomplete definition of done? All right, and the rest of you just here to hear what done actually means. Okay, you're in the right place, all right? So this is, I think we might call it code complete. In other words, we're kind of done with it. We might get something kicked back from QA, but this is us, we're kind of done with our part. Right? We just have to deliver the change to the customer. How hard can that be? All right. So let's talk about deployment. Is deployment done? All right. Are the changes deployed everywhere? All right. I don't know where it is for you guys, but for me, we have all these stages. So we have what's called a slow rollout, so that we only hit a certain number of people if something goes bad. So what is the pace of that deployment? If it's going to take a month, that has to be added to any estimate of what I think done should be. All right. And I've had this happen where I've gone, we had a problem, a serialization problem for my Linux migration. You had a thing, and then to check are we done? Yes, we're done. QA, is the problem going away? No, it's not gone away. So you didn't fix the problem. They go, well, the code isn't deployed yet. It's only in stage 1. It's like, I need it everywhere. I can't just take some machines out, right? And is there any staggered dependencies? There's projects where they have more than one moving part, and they have to have their stuff done as well, or your stuff doesn't work, right? They're driving maybe data to you. All right. And the thing that gets us, I don't know, it gets me a lot in Bloomberg is code freezes. When holidays or things are upcoming and you're thinking, we're going to be in there in January 2nd. It's like, no, you got Christmas and you got New Year's and all this kind of stuff where we have a 2-week lockdown. So that stops it as well. All right. Anyone, anything to add on this about deployment? All right, but everyone agrees if you don't deploy the code, you're not done, yes? Because I have people that disagreed with that, all right? Because I had them on the hook. Okay, feature flags. What is a feature flag, right? I don't know, maybe not everyone uses them, but usually in large corporate structures, we have these things called feature flags, which is the way you turn on and off functionality without modifying the source code. Because otherwise, I would have to revert the code to the previous version. And if I have half a dozen fixes in there, including some critical updates, I don't want to take everything back out. So it allows me to switch stuff on and off, right? So they're usually like if statements, like circuit breakers in the code, for untested code. Now, when I say untested, it doesn't mean we just wrote it and shoved it into production and said, let's see how that goes, right? Untested just means we haven't tested it in the ecosystem of production with that variability of data and the loads that go with it. All right, so that's a feature flag. So I just say, well, is the feature flag enablement done? All right, because deployed code, you would be amazed how I have to explain this to people. If your code is not actually switched on, you're not done. All right, it's not useful. No one's getting the benefit. So same way with deployment. Are they enabled everywhere in production? We also have this phased idea of turning feature flags on. What is the pace of that enablement? All right, is it weeks? Is it days? We have various cadences for it. And when will it be complete? Soon. Be complete soon. No, I want a date. Right? Tell me the date it's going to be done. Right? And then if you want to throw something in that's going to cause the beehive to get, let's say, well, when's that coming back out, right? Because a feature flag has a branch that's no longer being used when you switch it. Okay, so when is that coming out? Well, I'm going to deal with that later. So anyone, any questions, trouble? All right, so let's go to my software engineering pyramid, all right? And say that at the most basic level of doing change, we have this idea of being done when you have this amount of stuff done. Is that a 5 or a 3? 30, okay. All right, I'm an agent developer. What can I tell you? All right, so this is the stuff, all right. So this gives you survival. You can make change in your system. you can somewhat adapt to your customer's needs. So survival has been achieved, right? So it's the bottom level. All right. So congratulations, if you're doing this, you're a competent coder. All right. So let's move on from here. Is there a higher level of engineering? You know, I'm going to say there is. I'm going to give you some rationale. All right. So when is survival not enough? All right. So look, I'm pushing out changes. What do I need to think about anything else?
Documentation and training.
You're way ahead of me, Chris. It's not important anyway, right? All right. So any system where engineering is invested wholly in feature change or bug fix resolving, that code base is guaranteed to devolve over time into some complex, brittle mess that is going to be very hard to do the same quickness or change without breaking a lot of stuff. Okay. So companies need to balance rapid feature development against long-term product sustainability. All right? And if you don't believe me, look at some of the legacy code bases I deal with. All right? Where this has not been a thing. All right, so efforts are needed to stabilize or reverse the entropy that will come into a code base over time. So let's talk about some code health basics. All right, so what is software decommissioning?
The hardest thing in the world.
It certainly seems that way. All right, it is the strategic process of retiring outdated software and the stuff that goes along with it, right? And we do that to give better structure, better maintainability over the code. All right. I went into a bunch of code and thought, man, I'm refactoring this thing. I turned out to be in a piece of code that wasn't being used, but no one had never decommissioned it, right? I spent a couple of hours in it. All right. So we have two types, though, of decommissioning. All right, the first type is code that is structurally, you can't access it. Nothing is calling it, so it's a dead piece of code. All right, and you can usually find that with tools. You got, I think it's called Verity, CPP checks. Even a good IDE will probably find a lot of this stuff. And this is what I call the easy stuff, even though we leave it around a lot. All right, the other type is the functions are never accessed with the current data coming into the system. I have something that processes, in my case, tick type A. I don't know the tick type A comes in anymore. Maybe it comes in, every leap year or something like this. It's much trickier. You have to monitor production usage, meaning you have to have some instrumentation over length of time. And at some tick, go, well, it's been 3 months. I think we'll go with that. Right? If you're doing 3 months, I think you should do it like over the new year and the leap year in that 3-month period, right? Get everything. Right? And then feature flag removal. All right, that is a nightmare. It's the most simple thing to do. There's an if branch. If this thing is turned on, do this, else do the old thing. And I look at these things and it's, well, this was last changed 2 years ago. Right? No one got back to it. All right. It's pretty easy, but it's pretty dull. As engineers, we don't like cleaning up stuff, right? It's more exciting to write stuff than clean it up. So feature flag removal, we can automate it. I know we've automated somewhat on Bloomberg, and I know Google has it going on somehow as well. Don't ask me how I know, but if you can automate it, so much the better. You're reducing the manual toil. All right, so is decommissioning done?
Never.
Never. Well, are you doing anything decommission-wise? All right, is there any decommissioning needed? Maybe there's not. Maybe you live in a really special place, all right? Right? But the thing is, if you're replacing something, we plan to remove the stuff we're replacing, all right? And I've chased people down where I am going, we've just moved, this is the last use of this particular code. Have we decommissioned it? And I chased around, and to fairness, they went and did it, but it's taken about 6 months to take this stuff out of the code base. It's not just a delete. All right, it's all intertwined. It's a legacy code base, right? Feature flag removal, I talked about that. If you don't take out feature flag removal, right, with these dead branches, it's absolutely toxic when you try and refactor code, having these branches in it. All right, and then the other thing, and people say, well, this would only happen in old code bases. I don't believe it, but there's this stuff that we have standard algorithms, right? Standard concepts like partition, Right? I see people going, oh, I want to find all the type of X in this thing here. Instead of using partition, they'll do like, let's find and put it into another spot themselves, right? Or they'll do a find on their own instead of a find if. Optionals. And people are using pointers because they wanted to say sometimes it's not there, sometimes it is. Or they write their own class which has a flag of like, I'm good or I'm bad, right? You know, is valid. Or you can remove all that with optionals where we used small inheritance hierarchies. We can be using variants. All right, and for God's sake, stop throwing so many exceptions. Use expected. If you want to know why, go see my other talk on exceptions. All right, but these are things that we need to decommission in our code base to keep things, right? To stop us getting overwhelmed by the wave of legacy. All right, so let's talk about something else that's to do with code health, which is software refactoring. What is software refactoring? All right. It's the disciplined process of changing a system's software, right, without changing its functionality. Usually you're trying to make it, the internal structure better. Sometimes it's to make it more efficiency, but usually when you put efficiency in, you take structure out. All right. But that's what refactoring is, right? But why is refactoring needed? Why? Don't we do it right the first time? Isn't that the whole like myth of what we do? We do the best job the first time around. Because we do that, I'm going to be kind here, we do sometimes do tactical things instead of strategic. Like tactical meaning, I need to get this done now, I need to get it done quick. I realize I'm not doing it the best way. Right? And strategically, we should be doing it the other way, and we'll do it that way further down the road. All right. And it's usually this thing happens because we have time challenges. All right, we didn't allow enough time to refactor, or we didn't really research the code, so we hacked the code in. I've seen code that's been tons of templating, and someone then puts a real, like an if statement inside it, which just locks it down to some type now. All right, so they've just like frozen something that was malleable into like something you can't use anymore. All right, and then poor code reviews. All right. That's the other thing that happens, right? Where you're not under a time crunch. It's just people look at the code and go, yeah, whatever. I've coded worse than this. You can get it in. All right. So, and one other thing is no refactoring over time inevitably leads to a system rewrite. When you go, I need to rewrite this system, it's because you've let the tech debt consume you. You've let it like take you over. All right. So, is refactoring done? Well, have you done any of it, right? Do we need any? Have you put changes in where refactoring needs to be done? Have we got duplicated or recurring patterns in the code, right? Do we have code that's really unreadable, has all kinds of code smells, overly complicated, redundant logic, all right? So there's some kind of voodoo going on in the middle of it. And I've seen one where I think it was calculating n squared, and it said, while n plus plus is not equal to n squared, keep going. And there was a comment, I don't know why this works, but it's quick. All right. And then paradigm changes, right? We have stuff, we have more and more algorithms to use, transform, reduce, and all this kind of things. Let's stop writing our own stuff. All right. So that's code health basics. Oh no, actually it's not, I'm not done. What is technical debt? Come on, I got a lot of people in the room here. What is technical debt? If you don't know what it is, I'm really worried. What is it? Yeah, I'll word it a little better than that, right? It's the cost of reworking code, right, in the future due to quick fix or limited solutions you've implemented now. This is a pretty good definition, yes? I got a better definition because I sat down and thought about the stuff that really ticks me off on this stuff, right? And it's unnecessary complexity in the code base. All right, now just think, as an engineer, when you do something really, really very smart and tricky in the code base that no one else can understand, you're like, yeah, look at that. I mean, like 2 pages of comments for you to even get your head around that. So I think there's an argument you've just put tech debt in because you didn't use the simple solution. All right. So what are the things that cause tech debt? We talked about some of them, like deadlines. Other thing is firefighting. Something goes down in production or some change. I'm sure the CrowdStrike guys didn't take a lot of strategic thought into how to fix their stuff, right? It's like, just get it done. right? As I talk about some cleverness or premature optimization, in other words, I was also in a project where I was looking at the guy's code, and it's like, you've split your constructor into two pieces, and you got to manually call the second piece sometime later. It's like, yes, it's for speed. I said, I can now do 50,000 transactions a second in this part of the code. And I'm like, you're in a system where it's topping out at 2,500 transactions, right? Because there's other parts of the system. So what are you optimizing this part of the code right now, right, for something that you're just making the code harder to work with? Right, then you have a lack of standards and skills, all right? People don't care, or we just don't have good code reviews. And the other thing is organic growth. And, you know, I think legacy systems get a bad rap because you look at stuff and you go, what idiot did this, right? And it usually was, you probably did something pretty good at the beginning. Some idiot came in and hacked it, right, with short-term solutions. Are you saying that's what you did, Ben, or you have a comment?
I've done that in my time. That's what I was going to ask, though. Is tech debt in this metaphor always bad, or is it still something we can choose to do?
Oh, hold on. Ben, calm down. All right. And this all happens over a span of time. All right. Let's talk tech debt basics, right? There's a guy, Napton, which I like some of the stuff he talks about. There is nothing so permanent as a temporary solution or decision, right? I think these are, such a great phrase, all right? So we have categories of technical debt, and Ben, it's not all bad, okay? It's not all bad. There is this idea of intentional tech debt. In other words, consciously, for getting something time to market, fixing something that's urgent, we say, we are taking on tech debt. We are not doing the proper solution, but we have to beat someone to market, or we got to fix something. So we take this on consciously because we have a good reason for it. But we place this on some backlog to be mitigated. We intentionally say, we have brought in tech debt for good reason, and here's where we have a note that we have to get rid of it. All right, we do very little of this kind of thing. We should do more of it, right? Then there's unintentional tech debt, which I think is more common, all right, where it's just the result of a poor job. You didn't do it for any particular reason other than, it was easy. I don't want to say someone might be lazy, and there's no plan to mitigate it. It's like, someone will do an archaeological dig on this code 5 years from now. I wonder, what idiot did this? All right, so there's no plan to mitigate it. And the same guy said when he's doing stuff, a project isn't done until you go back and get rid of whatever you put on the backlog for tech debt. All right? And everybody agrees this is how we define done. All right? I don't know how many places you work that they believe that. Yes?
What's like an example of intentional tech debt? Like, can you give a specific example?
Yeah, intentional tech debt is I have some exchange giving me data, and I've got to calculate one of the parameters differently. And I just put an if statement in the middle of the code that calculates this. All right, and I go, boom. If the exchange is Tokyo, do this other thing. All right, and over time of all this, if the exchange is X, if it's Y or Z, that becomes a mess, right? So I say, look, that's not the way it should be done. There should be categories of data is processed this way, not per exchange. That's something that's either configuration or flexible, induced by the parameters of what's coming in. All right, so that's tech debt. Well, how do we track tech debt? And you should track it. You should make a list with the key attributes in it. I want to be able to come up with size and severity. Everything else just sort of applies to my area. But it should be size, severity. If it's something that's a little effort but gives you some gain, you go after it. Something bigger might take a much bigger effort, so it's harder to go after, but you have to make a case for it, right? And you need to be intentional. Let's get rid of the unintentional tech debt. Now, be intentional. I had, again, a code review I was doing, and I said to them, this is not the right solution. It works, but not the right solution. I said, yeah, but it works. And someone was like, yeah, I agree, it's kind of odd. So 3 of us thought it was odd. But it was the end of quarter, and to meet the quarterly goals, 2 guys on the team and the TL decided it's good enough. And I said, I'm okay with you doing that. Just put an item in your backlog to fix this tech debt. And they really had a hard time with me saying, you've introduced tech debt, because it seems like I'm saying their work is poor, or they have done a poor job, as opposed to you split the work because you have time constraints. All right, now to their credit, they actually have come along and actually fixed the tech debt because I kept on them. All right. The other thing is you need to keep it visible. Prioritize it on roadmaps. You know what that, we're going to get it now, right? I used to have this idea of a tech debt sprint. Once a quarter, right? 4 times a year, we had the sprint focus on technical debt. We had brought in the other 3. All right. But really, you need to advocate and champion for it. It's an insidious thing that just gets in. If no one is actively like watching out for it, there's kind of like these backhand handshakes. We're okay, right? Everyone's fine with it, right? But over time, you get a code base you can't work with, right? And you have to highlight the risks of this stuff. You know what? When this gets so complicated and turgid, time to market slows down. Reliability of change slows down, right? And you have this thing, the maintenance load goes up. All right, and I liken the maintenance load to if I'm in a lake or a swimming pool, and I'm trying not to drown, and I'm kicking my feet as hard as I can just to stop from drowning, but I have nothing left in me to make my way to shore. Like, what's going to happen eventually? I drown, all right? But I'm a decent swimmer, so that's not something I worry about. All right, so tech debt prevention. How do you prevent tech debt? Well, if you have coding standards and review guidelines, design reviews, which gets the stuff before people encode, dubious designs. And that you're tracking the tech debt. Track the damn stuff. You got to track it. Otherwise, you don't know it's there. How can you champion its demise if you don't even know it's there? All right, you do some training that helps with people recognizing it. I think the biggest thing then is proper timeline planning. Right? And there's a lot of times we introduce this because we're in a rush. And you ever heard the thing, for now? We're doing it this way, for now. You don't hear and forever afterwards, right? Because that's what happens a lot if you don't track it. All right. How am I doing on time? I feel like it's passing me by really quickly. Oh my God. All right. Okay. So have you all your testing pillars? When I went into this big project, they had no end-to-end or really unit testing. And that was the cause of the failure of the project for the last 3 times. And it was like, we need to get this right. Have you got these things? Because that's how you maintain quality in your code base, is through testing, right? And you have unit where you mock out classes and functionality, short feedback loop, usually easier to figure out what's gone wrong because when you piece it a system active, and you can do the happy unhappy path testing. You can do the integration where you mock out the executables, and you bring up your whole executable, and then it's harder because all the system is engaged. And usually you do only happy path testing, but it depends. And then finally you have system testing. So nothing's mocked out. You usually put synthetic data into your system. In my case, fake trades from a fake exchange. Long feedback loop, and it's usually much harder to investigate the errors because everything is in play, right? And it could be a change from some other group. So is the testing done? Are we creating tests based on production problems? Are we doing adequate test coverage? And I found that, again, the Gherkin style of test, I use robot as far as the testing framework. People can read the testing that aren't sucked into the technical details of the code and spot where you've gaps and stuff in it. All right. I moved the test down the feedback loop, right? End-to-end QA is a long time for the feedback to happen. Integration testing for me is usually an hour or 2, and unit testing is a minute. I compile, run it. It's really quick feedback. And shortening that feedback loop is key to getting something accelerated towards production. All right, and automating is key. So again, the rationale was survival is not enough because over time our code base will degrade and all the other stuff you're doing on that lower level of the pyramid, right, is going to have problems as your code base deteriorates. So I say there's a second level of being done, which is these things. All right, you're more interested, instead of just features, you're interested in your code base health as a whole. With the decommissioning, the refactoring, right, doing automation. So your system is now sustainable. All right? So we have achieved sustainability. Congratulations, you're actually an engineer now. All right? If you're working at that kind of level, if these are the things that occupy you when you're doing change. So that's going to be like, we're going to shift up a level, and here there's a qualitative change in the concerns. All right, down below it's more or less code. The features we're putting in, and then as we go up this pyramid, we're getting more into Shakespearean sonnets and stuff. So why is sustainability not enough? Right, well, that means you're keeping your current state of your code base pretty good, but code itself does not live in a vacuum. It has to run on stuff. It has to be in an ecosystem. All right, if your code is great and everything else is falling over, overall, your stuff is not good. All right, so efforts are needed to do capacity planning, reduce toil, and get general observability in the system. All right, so there's a change of emphasis. It goes from are we done to are we prepared? All right, and again, that's usually are you prepared? Probably not, unfortunately, again. All right. So why is that? Well, let's look at system reliability. How healthy is your system? All right, with all these changes flowing in from the various groups, what does the aggregate health of your system look like? All right. Can you catch problems in your system before the client does? Right, and if you only know that by knowing how close to the edge you're going. All right, so let's talk system reliability. Do you have system health monitoring? All right, so that's something, usually when you're larger code bases, if you're just putting a small app, this may not be it, but do you have the operational metrics? What we call LETs, latency, the time taken to do something. Is that climbing up? Right, when you see a spike, like I said, that time we had that big spike in latency, right? Are we able to track that? How is our throughput? Because even though our latency might not be great, we might have a high parallel throughput. All right, how is that doing? So you wait a certain length of time, but that's all you wait, even as we get bigger and bigger volumes of users or data coming through. Saturation, all right, how much percent CPU, RAM, oops. Anyone know what happened there? Reliability, right? One of the things. There we go. All right, so there. Well, like, so how close to the edge are we, right? Is our queue starting to saturate? Are we going to start dropping data? All right, and errors, the rate of failing requests or operations total requests. An error is not you return an error, right? I want $100 out of my ATM, but only $50 in the account. Error. You don't have that much money. That's not an error for your system. That's an error is when you improperly handle something. In other words, I give you the $100. That would be an error. All right. And any other metrics that are tailored for your system, right? Any system will have its own metrics that are important to it. All right. When you're using system health monitoring, do you have automatic alarms, right? The eyes on glass is a bad way to do it. Like, I would need someone sitting there looking at that latency spike to go, hold on. All right, just serendipitous I was looking at the code, but we really should have something that triggers. If it goes, the latency goes up this amount of time over this span of time, we'll then send an alarm out. All right, so we stop imminent outages. Something's running away and starting to deteriorate our system, kill it. Right, we monitor trends over spans of time because we want to do capacity planning. This is the curve of our saturation or latency. All right. We want to track that and say we need more capacity. We don't want to know about it after the problem shows up. We want to plan for it. And what about production support? Is there new technology or features that are being introduced? All right. Is it supported by current operations? I bring in a Rust program. All right. I wouldn't actually do it, but someone else did it, right? Is anyone else in the company able to do Rust? No, we're all C++ programmers. Well, then I need some kind of distributed way of doing triage, right? You can't have one guy go on a beach in Mexico and then nothing can move. I had that happen one time. Guy had a piece of code no one knew anything about. We were having problems, and I was like, he's not back from a beach in Mexico for a week. We have to wait for him. All right, so make sure it's widely known. We have proper support runbooks. People can deal with a lot of the problems. It's not focused on the one person. And now let's talk about strategic vision. Right? These are decisions that are not small features. They are decisions that affect long-term and future actions of your product. Right? You deal with shifts in business, new markets opening, changes in old markets, technology shifts. I'm going to move into the cloud. I'm going to use more AI. Right? And future-proofing, right? Stuff that's particular to your product. What do we need to stay competitive? All right? And for these kind of decisions, it's usually weighing trade-offs. There's usually not one perfect solution. You put those solutions up and you say, here's the pros, here's the cons, and this is the one that gives the most benefit with the least drawbacks. or it's the one we know most about, right? So strategic vision, how do we recognize it? There's usually more people involved than in smaller stuff. So the more people, the more strategic the decision in general. There's usually the time spans for making these are long, right? I mean, we didn't move to Linux on, 2 days notice, right? It took a long time for people to come up with what we're doing. So there's longer time horizons. The longer the time, more strategic. And the outcomes are usually hard to change. So once you set on a path, it's hard to change. I've just moved to the cloud. No, actually, we wanted to move to something more like a NoSQL database. Well, we can't do, we're committed. I've heard we are committed to the change. We can't come back, right? So they're not easy to change. Improvement planning, broad scale functionality changes, right? Many iterations. Right? We don't do the bing bang approach for reasons I already give, because we want to take the mitigation of risk and doing something wrong down. We have to predict timelines. There's longer time horizons, so there is less certainty. It's non-trivial stuff we're putting in. We're making major changes to the code base. We're going to have to plan for fixes. All right? And we usually have many external dependencies. And if we haven't worked on a really large project, the coordination and communication becomes really time-consuming to plan and keep everybody in lockstep. Right? It's much easier with a small group of people. Architectural design, strategic local re-engineer. And I say local because I'm not looking for a rewrite. If you do a rewrite, you've more or less said the game's up. Code base has gone to pot. I need to do stuff from scratch. Everything else is taken over. Right? Broad, complex changes in system architecture. I'm changing the way I do things technically. All right? Where we had pushing data and pulling of data all done in this one spot. There's a big strategic initiative to separate them out so that as we go forward, we have better response times on both. All right? So we have to have a vision for future performance and where to target systems for the most benefit, because you just don't, again, I don't want to say take the whole system and just crap it out. All right? I'll be back in 10 years with something that works about 75% of those operations. Right? That's usually not a good thing. And the other thing, are we leveraging existing technologies or introducing new ones? And you can introduce a couple of them, but don't change absolutely everything, because the new technologies don't advertise their shortcomings. And you will have the painful experience of figuring those out as you adopt them. So again, the rationale was sustainability is not enough because we live in a system. The whole thing has to work. So we have to live in an ecosystem. All right? And we need to manage that. So if I go to my pyramid, I have another layer of stuff that gets added in. Right? Where we're thinking about larger issues with our code. Right? And the aggregate health of our code base. So system reliability has now been achieved. All right, cool. All right, you're now a systems engineer, at least a competent one. It's great. So what do we think is at the top of this pyramid? So why is this not enough? All right, what's at the very top of the mountain? Engineering must be aligned with the business. All right, no matter how much you might dislike it, that's what has to happen. And efforts are needed to clearly communicate bidirectionally. All right, and we do that with what we call roadmap meetings. What is a roadmap meeting? It's a formal meeting, meaning we write down what's going on in it afterwards, where a group assembles to discuss the progress and future direction of a product or a large project. All right, and it's ensured that everyone, including the business, is going in the same direction. So have we got the business involved? Is that done? Well, what do you need at a roadmap meeting? You need a product owner, which could be you, could be someone else, who creates the roadmap, meaning all the deliverables and stuff we're going to be doing. You need development representatives from all the major areas so that they can talk about any roadblocks and effort and timelines that are involved to get this strategic thing done. You also need an executive stakeholder so that the decision-making process sticks. So someone higher up in the executive chain who can ratify the decisions. And you need a product manager or delivery specialist, all right? He is the guy, and I've worked with one, very good one, who does all the long-range timelines, puts it all together, and I say, this thing has been pushed out 2 weeks. He goes, well, your overall retirement date is now moved over into the next quarter, right? And we can feed it up that we've just blown from one quarter into another quarter. We've missed our deliverables, right? But we know it earlier, not when we miss it. We know it before we miss it. So what does the roadmap meeting address? It reviews the current landscape, right? Any progress and any roadblocks. All right, and we set strategic direction. The other good thing is I've had lots of problems where I go to someone, you need to fix this, yeah, and I'm not really interested. And when you're in a roadmap meeting and all very high-powered people are in it, and I go, we have a problem with some database stuff that hasn't been coded up yet. Over to you, database manager guy. And he's like, well, yeah, we're just about to get to that, right? It's much more public and visible, and that means that, we're all going in the same direction. So where are we going and how are we getting there and getting a consensus buy-in? So everybody is moving in that direction. We do resource allocation, what orders or items getting tackled and who's doing it. And then very important, the action planning at the end. We send out something. This is where we are going. And it's going to have who's doing what with dates attached, not sometime soon. All right. What about future planning? Are you prepared for things like software stability, security vulnerabilities, system scalability? All right. These are things you might have to think about when you're thinking about the overall product that you have. Are you ready for things like new technical opportunities? We want to move to the cloud. It's going to give us a great bunch of stuff. All right, new business opportunities, new markets are opening up. New regulation. We got to do this regulation by this time or else we're going to be fined. All right, and how do we stay competitive? How do we look ahead to say, let's not be complacent, let's look ahead and see where we're going to be competitive. So again, the rationale was, why is system reliability not enough? Well, engineering and reliability, engineering must align with the business needs. All right, and we need to communicate that. So going to our pyramid, at the very top is business needs and engineering goals. They have to be in alignment, and there has to be clear communication. So if you get these things aligned, what are you now? What do you think you are now? You're a visionary, right? You've somehow made heaven and earth come about, all right? So fair play to you, right? So this is the software engineering pyramids. Yes, Chris?
Before you get to the strategic steps, should there be a post-mortem to look backwards and say, where did we screw up? Where did we do right?
Yeah. That's more the processes. It's one of the things I have left out. It's in my other redesign talk. All right. So let me recap because I think I'm nearly over time. You have a question?
Recap and then I'll ask.
All right. So what level of software engineering are you operating at? All right. Are you a feature implementation bug fix guy? Is that what consumes you? Get that last erg of stuff out of your thing. Are you more concerned with code health and sustainability, how the overall code base is doing? All right. Are you operating where you're more interested in how the whole system is doing and how its overall stability and tracking that this thing is not heading over a cliff? Right? And are you looking for future direction and market competitiveness? They tend to align with the time in the business, so you'll generally be at the bottom of that list. I did it backwards because it's kind of like my pyramid again, right? Now you go the other direction. So to recap, software engineering, when are you done? What's the type of doneness? Specifically, what's the scope? These are all the things you need to worry about for scope of a project. What are you promising? What time are you giving? Have you built in some padding, as John called it? I call it a contingency time budget. Are you bringing in any intentional debt? And if you are, have you plans to get rid of it? And you're not done till you have that done. Are you communicating clearly to your stakeholders, your customers, what you're doing with regular progress meetings? And as the news gets, if the news gets worse as you progress along your timeline, you got to communicate that. All right. The earlier you communicate bad news, the less bad it is. All right, if you want to think of it that way. All right. So, when are you done? When you have all your features and changes running smoothly everywhere in production. It's well supported by the team. Your tech debt is decreasing and not increasing, and you're monitoring it. Your users and clients are happy, then usually so is the business. You have structured, maintained code so that you have happy developers and you retain your engineers. They're not trying to get out over a wall. All right? And you're poised to meet future challenges. All right, so I've just one thing to say finally. I have one final word on this whole topic. This presentation is well and truly done. Thank you. Any questions? Yes.
When without them feeling like I'm breathing down their back.
I think you have to just explain to them. You see, if you tell them, here's the date you have to hit, that's much trickier. By the way, the question was, how do you tell a bunch of happy engineers you want something done that they don't feel like they've been picked on, I think, right? Is that the question?
Yeah, how do you ask for a date without...
How do you ask for a date? You say to them, you give me the date that you're comfortable with, right? And then you write it down and you hold them to it. It's called accountability. Something we're pretty soft on, right? But that's the way I do it. I say, look, I'm not going to you give me the date you're comfortable with, all right? And we've agreed what done is because I've got acceptance criteria. Then I'll be back in 3 weeks. See you then. I'll check into it in a week and a half just to see if anything's changed. That's how I do it. All right, the guy behind you said he was holding on to something.
I was going to ask about the pyramid because I was thinking, shouldn't that be reversed? But then you briefly said that you did that on purpose, but I didn't understand why. And then second, the question of done, you talked about it in an overarching done, but because the level of influence that each people have in that hierarchy, maybe I'm in the current pyramid at the bottom. Maybe for me, done is I wrote my code, checked it in, tests passed, and I'm done. Or are you thinking in terms of without being done all over?
What did you agree to?
Done? Pardon?
It depends what you agreed to. I agreed to get this change everywhere in production, and then I agree I'm done. Yes.
Okay, so there's different levels of doneness as well.
Yes, that's exactly
Okay.
right. Different
And
types, I will say. Yeah.
Can you describe why you reversed it again? I didn't understand that.
You mean in that list?
For here, for example, to me, shouldn't business needs and engineering be at the bottom? Because from there you go to the code?
Oh, we're
And
going to
that's-
start at the bottom if you come into the field, right? You come out of college, you're not up there doing business needs and strategic engineering, right?
Build the foundation first.
Yeah, you have to put the foundation of the years in to build up facility with being properly putting changes in that are well tested, delivered, and meet the acceptance criteria. Then you move to the overall code base health, right? If I'm just coming in the door out of college, I'm probably not going to go to people, all right, show me your code base, let me see how healthy it is. Might be a bit presumptuous. And you probably don't have the skill set either. Okay. Anyone else? Can someone please pass the mic back?
In terms of getting buy-in for addressing tech debt, have you generally found more success with coming up with a sales pitch that actually convinces management that it's worth putting in the timelines, or do you just kind of pad your main deliverables to add extra room for tech debt?
Well, I've just launched an initiative where I am, which is going after tech debt in the form of refactoring code. So when I moved the code base over to Linux, we got about half of the latency disappeared. All right. And then it's like, but the code isn't that great. So now it's like to go after the next stage of making that better is like I can show the time to market is so long, right? And it's only you see that like end-to-end QA. I created a QA department as part of my migration, staffed with automatic testing and manual testing, so that I could see what stuff was fit for purpose. All right. Now I can just say, look at what's going on in your system, how hard it is to get change through, how serpentine people have to sit and look at your code for a week to make a 2-line change, for instance, right? And they're still not sure. So you roll it out at a glacial pace, right? And the thing they used to roll it out was 1 machine at a time, then 2 machines. But with the QA that's there now, they roll it out in a stage, 1 block of machines, then another block. So the rollout has sped up. So these are things that if you phrase it correctly, it takes some experience, some seasoning, you can convince the higher level managers this is what needs doing, right? But that's the easy part, because most people will go, yeah, tech debt reduction, that's great, we should get rid of it. And then it's like, well, give me resources, give me time, give me some of your people's. That's the hard thing, and for that you need to do, right, what I just talked about earlier, right? Putting some scope together, right? Putting people's names on it. Right, so that they're trying to have their performance reviews linked into it, right? Things like that. All right. Anything else? All right. Well, thank you. I'm done. Bye now.